Most of the people on your system are either obese or have metabolic syndrome or have insulin resistance. Um, the question that anyone asks is, why am I so tired if I have metabolic syndrome or type 2 diabetes? It is important that all of this has to do with glucose metabolism. It must be understood that in the cell, the glucose is being break down and eventually end up into ATP that supplies energy to the cell and to the body. You will see that the ATP is in the right corner after the process of oxidative phosphorylation. But to provide energy to the cell and to the body through oxidative phosphorylation, glucose must first enter into the cell, and that is where the problem is. As you will see in this diagram, there are insulin receptors, as illustrated here with the blue round area on the cell, and the yellow insulin must first sit on the insulin receptor before the glucose channel opens and glucose are allowed to spread into the cell. Now, this is the crux of the matter, and as you will agree, it is rather a complicated way to get glucose into a cell to do such an important function as to produce energy to the cell. To simplify it, I brought another diagram that again shows you that when the purple insulin is going into the insulin receptor, the green gate is opening up and the red molecules flow into the cell. That is a very important concept. Now, what happens to people with metabolic syndrome and people with obesity and type 2 diabetes is that these receptors for insulin is being blocked. There are several very complicated mechanisms why it is being blocked and how it is being blocked, but fact is they are blocked. I tried to simplify it with this sketch where you can see that V red on the receptor blocks the purple insulin to come and sit on the receptor, and thereby the glucose can't enter into the cell through the glucose channel. What happened then if these insulin receptors are blocked? In the first place, glucose can't go into the cell and the glucose levels in the blood rises, and that is the reason why we test all patients with obesity for blood glucose and insulin resistance. The second most important point is that glucose can't get into the cell to be transferred through the process of oxidative phosphorylation into the most important ATP that provides energy to the cell and to the body. The result is therefore obvious. The patient don't get ATP out of his cells from glucose metabolism, and that is why the person is inactive or lazy. How can we correct this problem of blocking of the insulin receptors to allow the glucose to get into the cells again? Although it is very complicated, the answer is obvious. All researchers agree that the most important way of getting your insulin receptors functioning again is by losing serious weight. To prove my point, I put in the words weight loss and insulin resistance into PubMed search and came up with research results of 5,870 topics about insulin resistance, obesity, and weight loss. Most of these thousands of research articles pointed out that if you lose serious weight, you can restore the functionality of your insulin receptors.